in the question they did not mention where actually the root lies. So what I want to do, I just want to use trial and error method. In order to get x0 value, what I'm going to do, I'm going to start substituting x value. When I substitute this one in my formula along with the equation, I'm going to get the answer 0.8551. Hello to all, a warm welcome to my new session on roots of equation. I'm your Revati ma'am from the Department of Computer Science, Vidhyaashram, First Grade College, the Temple of Excellence, MYSURU. So dear student, before going to start my today's session, let me to recall the topic what I have discussed in my previous session of this unit. So dear student, actually I started with regular falsy method, and this method is also known as false position method. That means in the exam you're going to get the question like by using regular falsy method or false position method, solve this equation. And what is the formula? You have to remember to solve the problem, that is x1 equal to a f of b minus b into f of a divided by f of b minus f of a. So dear student, first you have to find out a as well as b value, and at the same time you have to find out f of b and f of a and substitute the values in order to get the root. So this is the formula used to solve the problem by using regular falsy method. But in my today's session, I'm going to deal with Newton-Raphson method and secant method. So dear student, what is the formula used to solve the problem using Newton-Raphson method? That is x1 equal to x0 minus f of x0 divided by f dash of x0. So what is x0? In the question, they are going to mention what is x0. By using x0, you have to find out f of x0. Then what about f dash of x0? That means I want to differentiate the given equation. After differentiating, whatever the solution I'm going to get, that is my f dash of x0. Along with that, I'm going to deal with secant method. That means which algorithm I need to follow and what is the formula. So these are the two methods I'm going to deal in my today's session. Now I'm going to have the fourth problem, that is find a real root of the equation x e to the power x minus 2, which is equal to 0, and correct to 3 decimal place using Newton-Raphson method. So I have the equation. What is my equation? X e to the power x minus 2, which is equal to 0. And first what I want to do, I want to write this equation in the form of f of x or f of x0, that is x e to the power x minus 2. Now, in order to get x0 value, what I'm going to do, I'm going to start substituting x value, and when my x equal to 0, I got the answer minus 2, which is negative number, so which is less than 0. Now, when x equal to 1, I got the value 0.7183, which is greater than 0. Therefore, the root lies between 0 and 1. Now I came to know where the root lies. But here I'm going to consider x naught equal to 1, because when I substituted x equal to 0, I got some negative answer, and when I substituted some x equal to 1, I got positive answer. So I'm going to consider x naught equal to 1. Now, if I consider the formula, what is my formula? That is x1 equal to x naught minus f of x naught divided by f dash of x naught. This is the formula. And if I consider this formula, what are the things I required? I required x naught value. Along with that, I required f of x naught and f dash of x naught. Now, dear student, if I consider, I got x naught. What is x naught? That is 1. And when my x naught is 1, what is my f of x naught? That is 0.7183. And now I don't know what is my f dash of x naught. To find out f dash of x naught, what I want to do? I want to differentiate d divided by dx. And I have x ex minus 2. I have x, that is x ex minus 2. Now, if I consider this one, that's in the form of u and v. So, it is in the form of u and v. So, what I'm going to do? First, I'm going to differentiate v. Okay, then I'm going to differentiate x. So, first, if I differentiate ex, what is the differentiation of d by dx of ex? That's nothing but the ex. So, I'll get x ex. Okay, I'll get x ex plus, now I'll write ex itself as it is. And if I take the differentiation of x, that's nothing but the 1. So, I'll get 1ex. And if I take the differentiation of 2, that is the constant. So, I'll get the answer 0. So, what is my f dash of x naught? That is x ex plus e to the power x. See here, x e to the power x plus e to the power x. And if I simplify this one, what is common? E to the power x is common. So, I'll take e to the power x outside. Now, I have x and I have 1. So, x plus 1. So, this is my f dash of x. And what is my x naught value? It is 1. And when I substitute all these values in my formula, I'm going to get the value 0.7962. Now, this is my x1. So, what I want to do? Now, I want to find out the f of x1. See here, what is the formula for x2? That is 0.7962. So, this is my x1. Okay, now this is my f of x1 and this is my f dash of x1. And after that, when I substitute this one in my formula along with the equation, I'm going to get the answer 0.8551. So, this is my x2. Now, after this, I want to find the f of x2, and when I substitute this one, okay, when I substitute this one, see here, to find the f of x2, I have this equation, And to find out f dash of x2, I have this equation. And when I substitute the values, I'm going to get the answer 0.8526. Now, once again, I'm going to carry out my fourth iteration. And when I carry out fourth iteration, I'm going to get the answer 0.8526. Okay, in the place of 0.851. So, what is my final answer? That is, I'm going to consider only 3 decimal value, because in the question they mentioned up to 3 decimal place. So, to stop my iteration, I'm going to consider the fourth iteration value as well as third iteration value. And when I consider third iteration as well as fourth iteration, I'm going to get the answer 0.853. So, by using Newton-Raphson formula or method, I can able to find the roots of an equation. Now, I'm going to have another method called secant method. So, dear student, till now we discussed 3 types of iterative methods, that is bisection method, regular falsy method as well as Newton-Raphson method. But in my today's class, I'm going to deal with another type of method used to find the roots of an equation, that is nothing but the secant method. Now, what are the steps I need to follow while to use secant method? So, what is my algorithm here? In that, the first step is going to indicate that I want to find 2 values. What are the 2 values? That is x0 and x1. And how I'm going to find whatever the x0 I'm going to get, that must be smaller than x1. In the sense, this x0 is always my negative value and this x1 is always my positive value. And when I multiply f of x0 into f of x1, I'm going to get the answer which is less than 0. Once again, it indicates that it is negative. So, it is negative. Now, in my second step, I have the formula. See here. So, this is all about my x0 and x1. That means I got x0 as well as x1. Now, I want to find out x2. Now, I want to find out x2. So, this is nothing but my iteration 1. Okay. So, what is the formula? x2 equal to x0 minus x1 minus x0 divided by f of x1 minus f of x0 and whole divided by f of x0. This is the formula. And for my next iteration, by using same formula, I can able to continue. So, here I have the second iteration. See here, formula remains as it is, or you can able to change the formula. It's left to you. That means which method you feel easy, you can consider that one. So, dear student, I can use same formula throughout the iteration, or I can able to modify the formula. That is, if this is for my first iteration, then I can consider this formula for my second iteration. That is nothing but x3 equal to, see, I have x0. Okay, I have x0. So, here it is my x1. Now, see here, I have x1. I am going to make it x2 minus x1. Now, f of x2 minus f of x1 multiplied by f of x1. So this is for my second iteration. If I consider third iteration, that is x4. Now it is x2. See, 1 over 0 over, then it is 2 minus x3 minus x2 f of x3 minus f of x2, which is multiplied by f of x2. Okay, for the next iteration it is x5, and for the next iteration x6, and it's going to continue. Or by using single formula, I can able to find the result. Okay, that means by using single formula, I can able to find the root of an equation. Now, in my third step, see, if my f of x2, so whatever the x value I am going to find out, if it is equal to 0, that indicates that that's the exact root. If not, then what I want to do, I just want to interchange the value. That is nothing but if f of x2 equal to 0, then x2 is an exact root. Else x0 equal to x1 and, okay, so what I'm going to do, x0 equal to x1. I'm just going to move whatever the value which is present in the x1 to x0. Now x1 is empty, right? So I'm going to swap x2 value to x0. So I'm just interchanging the value. So x1 to x0, here x2 to x1. Now repeat this step 2 and 3 until ith iteration. That means until I'm going to reach 0 value, I want to repeat the iteration. So this is all about secant method, and this method is also used to find the root of an equation. Now let's solve some of the problems. So what is my first problem? Find a root of equation, and this is the equation I have using secant method. First, what I want to do, I want to write this equation in the form of f of x. After that, what I want to do, I want to start substituting x equal to 0. So 0 to the power 3 minus 0 minus 1. What is the answer? Minus 1. So when my x is 0, my f of x is minus 1. Now x equal to 1. 1 to the power 3 minus 1 minus 1. So this get cancelled. Once again minus 1. So when x value is 1, my f of x is minus 1. Now x equal to 2. So 2 to the power 3 minus 2 minus 1. So 2 to the power 3 is nothing but 8 minus 3. It is 5. So when my x is 2, my f of x is 5. So I got one negative answer and one positive answer. Now my x0 is 1 and x1 is 2. My f of x0 is minus 1. My f of x1 is 5. So I got the value. Okay, I got the value like x0, x1, f of x0 and f of x1. Okay, see here, I got x0, f of x0, x1, f of x1. Now what I am going to do, I am going to substitute this one in my formula. So what is the formula? This is my formula, x2 equal to, so this is my first iteration. See, this is my first iteration. Now x2 equal to 0 minus x1 minus x0, which is divided by f of x1 minus f of x0, and this whole thing is multiplied by f of x0. After substituting this one, I got the answer, that is 1.16667. Now I want to find the f of x2. So what I'm going to do, I'm going to substitute this value in the given equation. So after substituting, I'll get minus 0.5787. Okay, now I got x2 as well as f of x2. Now what I want to do, see here, this is not equal to 0. So this is not equal to 0. In the algorithm, they have mentioned that if f of x2 equal to 0, then I want to stop the iteration. If not, I just want to replace x0 by x1 and x1 by x2. Fine. So here, what is my x0? It is 1. I want to replace that 1 with the value 2. So I'll replace x0 equal to 2. Okay, when my x0 equal to 2, what is my f of x0? F of x0, that is nothing but the 5. Now see here, my x2 is nothing but my x1. So now whatever the x2 I got, that is my x1. Okay, so what is the x1? 1.16667. Then what is f of x1? That is nothing but minus 0.5787. Fine. Okay, now I got x0 and x1. Now in my second iteration, see here, x0 2, x1 is 1.1667 and f of 2 is nothing but 5 and f of x1 is nothing but minus 0.5787. Fine. Now I'm going to substitute this one in this formula and I'm going to get the answer 1.25311. And when I substitute this one in my f of x, I'm going to get the answer 0.028536. Okay, fine. Now this is not equal to 0, so I just want to swap. Now my x0 is nothing but my x1 and x1 is nothing but my x2. Fine. So what is my x1 here? That is 1.166 is nothing but the x0. So x0 equal to 1.1667. Then what of f of x0? Okay, that is minus 0.5787. Now x1 is free. So what x1 holds? That is nothing but the x2 value. So what is x2? 1.25311. And what is f of x1? That is nothing but minus 0.28536. Over. So this is the way I'm just swapping the value. Now if I consider third iteration, see here, x0 1.1667 and x1 1.25311 and what is f dash? That is minus 0.5787 and f of x1 is minus 0.28536. And when I substitute this one in this equation, I'm going to get the value 1.33721. So when I substitute this value in this formula, I'm going to get the answer 1.33721. Now if I find the f of x2, I'm going to get the answer 0.05383. Okay, fine. Now what I want to do, I want to check this one, is it 0 or not. If it is not 0, I just want to swap. After swapping, my x0 is 1.25311 and my x1 is 1.33721. So dear student, I will tell you whatever my previous iteration value, I want to consider that one as my x0, and whatever the present iteration value I have, that is my x1. Okay, after that I'm going to substitute these values in this formula. After that I'm going to get the answer 1.32385. And if you check all the iteration, I'm going to consider only 3 values, that is x0, x1 and x2. That means in this way also you can able to solve the problem. Okay, this method also you can follow. Now I'm going to find the f of x2 and I'm going to get the answer minus 0.0037, which is not equal to 0. If it is not equal to 0, what I want to do according to the algorithm, I just want to repeat second and third step. So I'm just interchanging the value. So I got x0 1.33721 and x1 1.32385. And I got f of x0, that is 0.05388, and I got f of x1 0.0037, and I'm going to substitute all these values in this formula. After substituting, I'm going to get the answer 1.32471. Now what I want to do, I want to find out f of x2, and when I substitute, I'll get the answer minus 0.00004, which is approximate to 0, okay, which is near to 0, so that I can able to stop my iteration. So the approximate root of the equation x cube minus x minus 1 equal to 0 by using secant method is 1.32471. So dear student, let me to explain another problem under this method, that is find a root of an equation f of x equal to 2x cube minus 2x minus 5 using secant method. And what I want to do, I just want to write the equation in the form of f of x. Now what I want to do, in the question they did not mention where actually the root lies. So what I want to do, I just want to use trial and error method. So dear student, start substituting x naught, that is equal to 0 or x equal to 0, and it will become 0 minus 5. The answer is minus 5. Now x equal to 1, 2 to the 2 into 1 to the power 3 minus 2 into 1 minus 5, which is equal to 2 minus 2 minus 5. So 2 get cancelled. The answer is minus 5. Now x equal to 2. 2 into 2 to the power 3 minus 2 into 2 minus 5. So 8 into 2, 16 minus 4 minus 5. So what is the answer I'm going to get? I'm going to get the answer positive 7. Now I got one as negative value and one as positive value. So I'm going to stop the substitution and I'm going to consider the root x naught equal to 1 and x1 equal to 2. See here, it is 1, 2 and minus 5 and minus 7. Now see here, x naught 1, x1 2, f of x1 minus 5 and f of x1 it is 7. Okay, now what I'm going to do, I have the secant method formula. Now I'm going to substitute the value. After substituting, I'm going to get the answer 1.41667. So this is my first iteration. And what is my f dash of x2? That is, I got the answer minus 2.14699, which is not equal to 0. So if it is not equal to 0, what I want to do? I just want to swap the value. That means I just want to make it x0 equal to x1 and x1 equal to x2. See here. Now I'm in second iteration. I have the formula. X1 is 2 and x2 is 1.41667. And here f of 2 is 7 and f of x2 is minus 2.1466 or minus 2.14699. See the modified formula here. If I consider previous example, in all the iteration, I'm going to consider same formula and I'm going to have only x2. See here it is x3. When it is x3, then x1 minus x2 minus x1, f of x2 minus f of x1 multiplied by f of x1. And when I substitute the formula, I'm going to get the answer x3 equal to 1.55379. Okay, and when I substitute the answer in my f of x3, I'm going to get the answer minus 0.60759. Okay, fine. In my third iteration, I'm just going to swap the value and I have my x2 and I have my x3. Now I'm going to substitute all these values in this formula. Okay, see here, it is x4. When it is x4, x2 minus x3 minus x2 divided by f of x3 minus f of x2, and it is whole multiplied by f of x2. And when I substitute the value, I'm going to get the answer. That is my x4 is 1.6073. And what is my f of x4? That is 0.09449. Now, which is not equal to 0. So, dear student, we are in fourth iteration and I have the value like x3 and x4. I got x4 and I got x3. That means after finding out f of x3 and f of x4, I got some value. Now I'm going to substitute these values in this equation. And after substituting these values in this formula, I'm going to get the answer 1.60037. Okay, and after finding f of x3, I'm going to get the answer minus 0.00324. Now, dear student, in my fifth iteration, see here, I have x4 and I have x5. Now, I want to find out f of x4 and I want to find out f of x5. So, I got the answer. Here I got the answer. Here I got the answer. Now, I have the secant method formula. So, what I want to do, I just want to substitute the formula. After substituting the formula, my x6 value is 1.6006. And if I take f of x6, I'll get the answer minus 0.00002. So, which is equal to 0. So, which is nearer to 0. So, which is nearer to 0 in the sense what? I can able to stop the iteration. So, I'm going to stop the iteration. And I'll write approximate root of the equation, that is 2x cube minus 2x minus 5, which is equal to 0, by using secant method, and I am going to write my x6 value, that is 1.6006. So this is the way I can able to find the root of an equation by using secant method. Anyway, dear student, in my next session, once again, I am going to discuss few more example under this method. So dear student, let's meet in the next session with more example problems. Until that, keep watching and keep learning. Thank you.